Almost all statistical methods are based on the notion of implied randomness. If observational data are not collected in a random framework from a population, results from these statistical methods are not reliable. So, for this video, I'm going to consider 4 random sampling techniques: simple random sample, stratified sampling, cluster sampling in multi-stage, and systematic sampling, which is sometimes random. Alright, simple random sampling is probably the most intuitive form of random sampling. Cases are randomly selected from the population until the desired sample size is reached. So they can be anywhere from the population. Consider the salaries of Major League Baseball players, where each player is a member of one of the league's 30 teams. To take a simple random sample of 120 baseball players and their salaries from the 2018 season, we could write the names of the 877 players of that season's opening day roster onto slips of paper, drop the slips into a bucket, shake the bucket around until we're sure we have the names all mixed up, then draw out slips until we have a sample of 120 players. Right. Stratified sampling is a divide and conquer strategy. The population then first is broken up into groups of similar groups called strata. In this case, these are broken up in terms of different colors. And then what we do is we randomly sample from each group. So the idea is you break into groups and then you randomly sample from each group. For instance, you can stratify by gender. You can stratify by political party affiliation, Democrats, Republican, Independent. You can do it by religion, by race, or whatever, but the idea is that you break into groups and you sample from each and every group. So the strata are chosen so that similar cases are grouped together. And then we'll use a second sampling method, usually simple random sampling, within each group. In the baseball salary example, each position, like pitcher, catcher, shortstop, could represent a different strata. We might randomly survey 10 players from each position to make up our sample. Similar to stratified is cluster. In cluster sampling, we group observations into similarly diverse groups called clusters. Then we randomly choose some of the clusters and sample everyone in those groups. So in this case, stratified sampling, we want it to be as similar as possible for each group. In cluster, we want the groups to be as diverse as possible. So we break into groups, and these are often like, say, geographic, different cities or counties. And then we choose some of them. And then we take everyone that's inside those groups that we chose. Sometimes cluster sampling can be more economical. That is, it's generally cheaper than other methods. Also, unlike stratified sampling, cluster sampling is most helpful when there's a lot of case-to-case variability within a cluster. But the clusters themselves don't look very different from each other. So in the baseball salary example, each of the 30 teams could represent a cluster. So we might randomly sample 4 of the teams, then survey every player on those teams. Alright. Suppose we're interested in estimating the malaria rate in a densely tropical portion of rural Indonesia. We learned there are 30 villages in that part of the Indonesian jungle, each more or less similar to the next. So what sampling method should be employed? Well, if we use simple random sampling, we would likely have to go to all 30 villages. And stratify is not really clear how to break this up into groups. These different towns are more like clusters. So since all the villages are more or less like each other, it would make sense to just pick some of the villages and sample from them. So a simple random sample would likely draw individuals from all 30 villages, which would make the data collection extremely expensive. Stratified sampling would be a challenge since it's unclear how we would build strata of similar individuals. However, cluster sampling seems like a very good idea.
we might randomly select a small number of villages. This would probably reduce our data collection costs and substantially in comparison to a simple random sample, and would still give us some helpful information. Okay. One note, with cluster sampling, you pick groups and then you take everyone in those groups. Multi-stage sampling is like cluster, except you have a second layer of random sampling. So multi-stage sampling is similar to cluster sampling, except you randomly choose groups and then you do a random sample within each of those groups. For instance, if we sampled neighborhoods using cluster sampling, we would next sample a subset of homes within each selected neighborhood if we're using multi-stage sampling. Alright, finally, systematic. In a systematic sample, a starting point is randomly selected, and then every kth piece of data from a listing in the population is added to the sample. So in systematic, only the first person is randomly chosen. After that, you do every second, every third, every fourth, every fifth, whatever you need. So in this case, I randomly sample, and then randomly sample. Just after that, after the first sampling it's the only the randomness is in the first sample. After that, it's no longer random. So for example, suppose you have to do a phone survey. Your phone book contains 20,000 residence listings. You must choose 400 names from the sample. Since 20,000 divided by 400 is 50, there's your math for today. You could randomly choose between 1 and 50 to represent that first name, and then take every 50th name after that. Assuming there's no pattern in the list, your sample should be representative of the population. Now, the advantages of systematic samples is that it's fast and convenient when you have a list. So this really only works if you have a small or moderate sample size. The disadvantage is that a systematic sample might lead to bias. If the population is arranged in any kind of repeating pattern, then systematic will not work, or will not give you good results. For example, suppose you chose every 10th person from a list that's arranged boy, girl, boy, girl. Well, then your sample is either going to be all boys or all girls, and not representative of the entire population.